Let the composite ARF Rebel Hot begin. We've had this Rebel Hot here sitting in the shop for quite a while now, and it's time to get this project underway. The owner has graciously been very patient and said he has no problem waiting for the project to begin. So thanks, Lewis, for being patient, and it's time to get this thing started. Now, this aircraft has been opened previously. We opened it up to take a look at it during one of our lives months ago. So we're not going to do an official unboxing, but we're going to pull everything out of the box. This is the Rebel Hot, so it's the smallest Rebel they make. Very cool little plane. The paint scheme on this thing is gorgeous, so I'm excited to get this thing out of the box. So let's pop it open, take a look at our equipment and the cool layout we are putting in this aircraft. All right, so just pulled the top of the box off. Nezzy's helping us inspect it, and that's what it looks like. So there's a bunch of things in here that the owner has put in. So I think there's servos in here. We've got a CARF tank. So we're gonna pop all the packaging out and get that plane out of the box. Now we're gonna save all this stuff. The Rebel Hot, the fuselage is this length of the box. So this is a great box to ship it in, Nez. And so we're gonna save this box for that purpose. All right, and there she is, the orange scheme, very, very nice. Looks absolutely awesome. So cool little plane. This, the little Rebel Hot is pretty darn cool. I'm gonna pop the canopy off. There we go. So pretty typical Rebel layout. Everything is the same as normal. It's just smaller. So that's basically it. That looks really nice. Yeah, let's take a look at the equipment that's going in here. Some of the things I like about this one already is obviously the vertical is permanently attached. Just a cool size plane as well. Looks really good. Really, really good. All right, so we've got the CARF tanks here. This is beautiful, and we've got some 3D support holders and stuff. Thanks, Lewis, for those. I know he included those. Have the landing gear. This is the JP landing gear for this aircraft. That's good. One of the things I'm excited to see is the RB45 gear controller. That's definitely my preference versus using the JP one, so that's great. We've got some jetty items here. So we've got a Rex 10, an R900, and a what's that? That's an R3, so that's our on-off switch. So that looks pretty stinking good. I like that. We've got some servos here. So these servos have been provided by the owner. So these are King Max servos. It looks like we've got the same servo throughout here. 1, 2, 3, 4, 5, 6, 7. Yeah, looks like the same servo throughout all of them. And we've got our parts from CARF. So just a quick little bag here. The basic manual, which doesn't really tell you much, but that's our hardware. Not really sure what this stuff's for. Looks like maybe pipe supports or something. Anyways, I don't know what that's for. We'll figure that out. Oh, I believe this is the single wall pipe. That's what that is. So we're not using that single walled pipe. Yes, that is what the is in there. So this is a custom pipe that he got made. So if you're using a 45, you may use something like this, but you can see the size difference here versus the stock pipe. Totally different layout. Watch out, Nezzy. So very, very different size. Now that brings up the engine that we're installing in this aircraft. So we've got an X60 that we're installing in this aircraft. So this is what is going to be the power plant for this thing. Now, a big power plant for this aircraft, it would easily fly off of a 45, but heck, a 60 is just that much better. And then, like I mentioned, we ordered the stock pipe for this aircraft as well. So that's what's in there. So that's all the parts that were in the box. I think have to look back on the history. I believe we're putting a Cortex in this thing. I'll have to figure that part out. But yeah, there she is. There is the setup. All right, so it's been quite a while. I had to review some of my emails and notes and stuff on this aircraft. So here's some of the additional parts that we'll be putting in this aircraft. So we're going for a very light install. Now, as we do on some of our previous built Rebels, like mine that's way back there on the top shelf, single battery is normally what we would do. The owner of this aircraft really wants to go with 2 batteries. So we're going to do 1 battery for the turbine, 1 battery for the electronic system. I would be installing 1 battery, but totally fine. We'll go with 2 light batteries, no problem at all with that. So he also wants to put an M-speed sensor in there, so we'll probably end up doing that just like we do on our normal Rebels and putting that in the front of the aircraft. Rex 12, which is ideal for this type of setup because the DSM-10 pairs nicely with the Rex 12. So this has the MPX connector here, which plugs right into the Rex 12. So this setup here, and also a Cortex as well too that we're putting in the aircraft. So yes, we are putting a Cortex in. So this setup here, actually we've got 12 channels through the Rex 12, we've got 6 channels through the Cortex, so conceivably with this setup you actually have 18 channels. You can access 19 if you really want to, but yeah, so that's how this is all going to be set up, and it's going to work beautifully. So that is the equipment for this aircraft. And one last thing I almost forgot was our mini Model Aviation Products UAT. So that's what we're going to be putting in this thing again. Lightweight is the key. So this is their mini air trap, which is awesome for this type of setup. 2 ounce, nice size, great size for like a 60 or a 45 size engine. And part of the reason why it's so perfect is because it doesn't take much room at all. You know, if you start going with some of those big UATs or even the bigger map UAT, it's going to be a lot bigger in this area, which is just a little bit excessive. So Lewis also shipped me these covers here. Now, if you've watched our previous Rebel builds, you'll see me use this on mine and my friends. And I forget what technology this is, but this isn't like the standard 3D printing technology. This is beautiful how this worked out. It's so nice. Anyways, that's the nose cover for this aircraft, which is perfect. So that guy will go right in there. I think we're a little bit narrow on there compared to the opening, so we'll have to see how that all works out. But anyways, that's the cover for the inside. All right, so first step as per normal is to set up a new model on our Jetty radio and go in and update all of our devices. So in this case, we've got a couple Jetty devices to update, but that's basically the first step. So let's get that done. Nothing overly exciting. We're just going to use our standard model, duplicate that, and that's how we're going to set this plane up. All right, so just taking a look through things here, and I got to say this CMJets tank is such a great idea for this aircraft. So you can see here how it fits. So basically it fits, the main part of it is right behind the wing tube. So the CG on the Rebels are essentially the back of the wing tube. So this is like right over the CG, such a great idea versus the stock CARF tank. All the other bigger versions are going to go in this area here in front of the wing tube. So this is a great addition. We've got this thing included here as well too, which I'm assuming is going to hold the tank down, which is cool. And yeah, that's really wicked. That's kind of nice to see. I thought I would just, you know, sidetrack a little bit. This is the Zykoy X60. Such a cool little engine. This, I think, is almost the same size as the 45. But I mean, it's such a baby-looking little engine in this aircraft. It's crazy how small that is. So anyways, that's what it's going to look like. It's going to end up being back in this kind of area right about there. So there'll be no problems with spacing between the tank and the engine. Very cool. All right, so this is our receiver setup for this aircraft. So we're using the Rex 12 as our primary receiver. The R3 is just our on-off receiver that operates the DSM-10 power switch. And then we're going to put a 900 backup in here as well too. And that's the setup. So what we're going to do initially is we're going to bind the Rex 12 to the radio, not worry about anything else. We will worry about those other things, the Cortex, the power, all that stuff at the end or near the end of the project. All we want is the Rex 12 to be able to go through all of our channels and set all of our servos up. Now I have made up the model here. So we've made up the Rebel Hot model, and I'll just show you our channel layout. So I went in there and copied my default model. We've got our function assignments, sorry. We've got our servo assignments here. So this is our basic servo assignment. So initially we've got to have our surfaces that we want gyro controlled on our first 6 channels. So we've got aileron, aileron, elevator, elevator, rudder, nose wheel. Those are all going to go into the Cortex itself. And then our 7, 8, 9, 10, 11, 12, those are going to plug in to the Rex 12. We do have the option of the first 6 channels on the Rex 12 to be programmable, but we're not going to do that because this plane uses 12 channels. We're just going to continue. So port number 7, for example, would be our first flap. We may mix things up a little bit because we'll probably be using our E2 port, but we're going to try and keep those as close to the actual numbers as possible. So ready to bind this to the system and start getting things set up. All right, so that's all bound, ready to go. Now I'll go in on this build and I'll show you guys some of the basic things that we do right away. So paired my receiver up in advanced properties, wireless modes trainer, so that's done. And then we go into our model menu and model menu, device explorer, and into the Rex 12 device itself. So general settings, this defaults to like 17, I think. I dropped it down to 11 ms and up the alarm voltage to 7 volts. So because we are going with 2-cell LiPo, 7 volts would be a good number because the battery's getting pretty low if you're at 7 volts. So that part is done. And then fail safe, we won't do anything there. Alternative pin configuration, this is fine. We're going to leave this as is right now, but we may go in here and change our E2 and E1 ports as well. Receiver outputs, again, this is all standard right now for our channel layout, but those are programmable. So that's some of the basic get going things here. And now we can pull out our surfaces and start going with our install. So like normal, we are going to start on the back of the plane, work our way forward. So the first thing I'm going to do is our elevator servos and our rudder servos. The rudder servo is on the actual surface itself right there, so nice easy access. So that's the stuff we're going to get done initially. What I'm planning on doing here for our equipment is a sort of Bluetooth type setup. Now, I'm probably going to end up building a bit of a tray right here in this area, right where my hand is. So that's where our equipment's going to mount. So it's going to be nice, hidden, out of the way, close to the CG point. And so I'll plan my wires to come to basically right about here ish. So we've got lots of extra lead to run things. So that's the initial plan. So we'll pull our elevators or horizontal stabs out. All right, so pretty simple stuff. This is the normal CARF bags that come with their aircraft. And pull both of these guys out. So there it is, nice gray finish to match the fuselage and everything. The servo in this guy mounts in the root of the horizontal stab, and you can see there where it comes out, and pretty normal stuff here for the Rebels. All right, so like normal, we want to make sure we cycle our servos. So this is a normal procedure for us here at the lighter side of RC. I call it burning in our servos, but essentially what we're doing is we are cycling the servos for 990 cycles. Why 990 cycles? Because that is how many the Jetty box does as a max number. So 990 cycles, okay. We do the full range of motion and a speed of 30. I don't know what that relates to, but V30, velocity 30, and there we go. So this takes about maybe 15 kind of minutes per servo, and you could use a Y cable, and yes, you could put multiple servos on there, but that's what we'll do for all the servos. Now, people always ask, why do we do that? Well, if you're going to have a problem with an electronic device, generally it's going to show up in the beginning part of its life. So that's why we do it. So I've had many servos over the years. Yeah, many servos is probably a fair thing to say. In the grand scheme of things, not very many, but many servos in the past few years that have shown issues on this portion of the burn-in process. So they get hot, they seize, they fail. Yeah, that's basically what happens, and that's when we want this problem to show up, not on the first flights of the aircraft. All right, so normal CARF stuff here. The bags are all labeled. So the stab bag is the horizontal stab. So we've got our setup here. Great setup. I love this setup. So we've got clevises on both sides, which is awesome. So the nylon horns that come with the servo will be perfect for that. And then the single G10 horn here is also perfect for a clevis. Obviously, they've drilled the holes to be the right size. That is good stuff. Other thing with fuselage is generally I would love to paint the inside of this fuselage, but at the owner's request, he wanted to keep it as light as possible, and that is the goal. So we're going to skip the painting process on the inside. That's okay. It's still going to look good when it's done, but it's a hard one for me. All right, so still cycling the servos away. These servos are actually, they're not even getting warm during the test run here, which is nice. So as I cycle them and as they pass the inspection, they get a check mark on the underside. So I'm just going through that. So as we work on the horizontal stabs here, just installing a servo loosely to check on the alignment of everything. So what I'm looking at is, does our servo arm line up with the slot? Which in this case, it does perfectly. So that's a great setup here. We will have to elongate the slot a little bit, and we are setting these up with our output shaft towards the elevator surface itself, which is going to make for a shorter linkage. So that's how we're setting this guy up. All right, so the other reason to put our output shafts towards the surface like this is when you put this in, you can simply put the servo like that orientation, install the servo, and then the arm has enough room to come up out of the slot. So obviously the slot is going to need to be cut or lengthened a little bit longer. Now these stock servo arms, I don't know if they're going to provide enough movement without touching the surface. That's not really a big deal. Basically, this slot just needs to be widened a little bit to allow the clevis to go inside the surface. So not really a concern much, but that's just something to think about when you're setting this up. Obviously a little bit longer servo arm would be okay as well, so we'll keep an eye on that and see. So we've got one of our tail surfaces complete here. This is the left side. You can see here the difference on how we open them up. So this one allows the clevis to go inside the surface, which gives us plenty of movement, which is awesome. We just do this with a Dremel, and then I take a hand file, just a little guy like this, and just clean up the edges and make them nice and square. So, and all that can be done after the servo is installed like this. Yeah, so basically it's not that complicated. Anyways, we're gonna get the right side done complete now, and then the elevator or horizontal stab surfaces will be done. All right, so both of our horizontal stabs are done. We're gonna set those aside for a little bit. We will be putting some ashlock connectors on the leads here, and then doing the same thing on our fuselage side. But because we're getting close to the end of the night, we are going to focus on getting our wheel housing or cover installed here. Now, a couple things when I'm installing this. Number one, we're not quite tucked up to the former work here. So what I'll do is I will sand the corners of this out just to allow a little bit of room there for the glue joint. So that's going to be the first thing we do. And then what I'm going to do is I'm going to spot glue this in place with some CA. Okay, so we're going to get that fastened down nicely with some CA. And then I'm going to tape over these joints right here. And ideally we're going to install Hysol all around the perimeter. So the reason we want to tape that joint is because when we tape it, run Hysol along that side, it's going to create a nice fillet that's going to, number one, join these two pieces together structurally, but also fill this in nicely as well too. So when we take that tape off the underside, it will look nice and smooth, and we can address it after that. So that's going to be the next thing we work on tonight, so we can get that curing and set up for tomorrow. All right, so we got our wheel cover glued in place. You can see we used Hysol all the way around the perimeter, and worked out good. That looks awesome. This material, whatever this 3D printer stuff is, I don't really like it because it's pretty absorbent. So you can see here where I had a little bit of high sol on my fingers. Obviously it doesn't just wipe off. I'm going to try and wipe that with a little bit of alcohol, but that's the only downside with that stuff. But otherwise it looks really cool and it's smooth. Got the gear in here just because I just want to make sure, I wanted to make sure that it can go in and out with this on. Which it does totally fine, that's no problem. I just left it in there while I was gluing. So anyways, we're gonna leave that to cure overnight and we'll revisit this tomorrow. So with both of our horizontal stab surfaces complete up to where we need them to be, we've taken the cover off of the vertical stab or the rudder surface, and we're gonna get our servo set up for this guy. So it looks like there's going to be a retainer piece. I think there's a carbon plate that holds that servo in place, so should be a nice system. So let's pull out the hardware and see what we need to do about this guy. All right, so we got our hardware package out here. Everything's complete like normal CARF fashion. We've got our linkage set up and we've got our retainers for our servos or servo. So we're going to take a look at a couple things. First thing I do here is I put the linkage together and confirm what position we're putting our servo in. So not that it really matters because you could do a shorter linkage if you wanted to, but the rudder, generally you're always doing the longer linkage, so like this. So we know that our servo output shaft, if this is the cover plate here, servo output shaft needs to be on this side. So what I'll do to keep things simple and not mess it up is just put a mark like that. So I know which side my servo shaft now sits on. And just confirm, yes, that is correct. So we've got one of our tested servos here. That's going to sit like this. Our retainer sits like this. We need to do a little bit of sanding on the base of the retainer here. You can see right down in this area, we need to sand a little bit of the wood away. That's no big deal. And then what we'll do is we will sand down our actual carbon surface here, and that will allow a good gluing surface for our servo. So rudder servo is all mounted. Great mounting system. This is incredibly strong for such a small little plane. So everything gets bolted in place. We glued the outside plywood piece. The servo gets bolted down with this carbon piece, so really strong. Very nice little setup. Also took my Dremel with my 1/8 carbide bit or 1/4 inch carbide bit and just cleaned up the opening here. So the fiberglass was kind of overhanging the wood. So you have to clean that up a little bit to allow the servo to actually fit in there. And that's ready to go. So I talk about this often. This is one of those situations where you could have this servo installed and you could have the servo lead running down and forward in the plane. The problem with that is this connection now becomes almost inaccessible with the pipe installed and everything. So what you want to do is you want to make sure that you bundle this up or shorten this lead up. We're probably going to shorten this lead up because there's not a ton of room in there, but I'll see. And you want to have this, let's say, bundled and located in this servo pocket. So if this servo ever needs to be changed, you pop the cover off, you have access to the connection, put the new servo in, do up the connection, and you're good to go. So kind of one of those important little things. And you know, we haven't had a tip time in a while, so that's going to be a tip time, and that tip time has been brought to you by Trusty Bent Screwdriver. Thanks, Trusty. It's an oldie, but a goodie. All right, rudder servo is ready to go in. So we've got our connection done up here. We've got our connector shrink tubed. Yes, there is a lot of space in the front part of this, this pocket here for our excess wire. So that's where we're going to run it. So we're just going to run it forward through the piece of reinforcement right here, and then down, and that's where our elevators are going to run as well too. So we'll get that mounted. You do have to drill your holes there as well, so we'll use a 1/16 drill bit here, and these are the screws that you're using to hold the rudder servo in place. All right, so we've got our rear leads done up here. These are our elevator leads. So we've got our ash lock connector installed on here. This is a locking connector, and we will use obviously the other side on the surface side. But I put some shrink tube around the first 6 inches, 8 inches of this wire. Reason is the wire goes in and there's a carbon piece that it goes through with a hole in it right in this area. So we want to protect the wire while it's going through that carbon hole. So it comes to about here, and then just switches to wire. I think I can show you guys there. Yeah, at the top of the screen you can see the carbon with a hole that the wire goes through. So anyways, that's how we do this up. They go through a 3-4 millimeter through fitting that we have here. These are available on our website, but I love them for scenarios like this. And we've got that positioned back from the anti-rotation pin a little bit, just to make sure that we've got enough room. And once they're installed, that's what they look like right there. So I'm going to get the other one installed, run forward, and these wires, obviously we are going to pin them against the fuselage up out of the way, and we'll probably have those wires either come underneath here or down low as they come forward in the aircraft. All right, so tail sections are installed. So on the actual elevator horizontal stab surface, I end up cutting that much of the servo lead off because it only needs to come out about this far. So we cut that off, put our ashlock connector on there, and that works great. Also have not installed the rudder linkage. Reason being is because we don't have any way to center the servo. Obviously we can get it close, but I'll just wait till the receiver and everything's installed in the plane, and then we'll get that perfectly set up from the get-go. So we're gonna get our wires fastened up and secured on the side of the fuselage, and then we need to get our pipe installed. All right, so we got the pipe installed in the aircraft. It's just sitting in there. It's not screwed down yet because we got to get the engine installed. You can see back here how it fits. Had to do a little bit of sanding with the Dremel on the top of the opening there just to allow that pipe to fit, but otherwise it goes in pretty straightforward. I'm just weighing up the engines here. So this is the 60 that's going in the aircraft. This thing will fly on a 45, but like a 60 or 70 is, as the website says, almost too much. So on the 60 Zykoy bare engine, we're at 467 grams. Now one of my friends is putting a 95 in his Rebel Hot, and the difference is 752 grams. So you are, what's that, almost 300 grams difference? Yeah, so about 300 grams difference, so you're 3/4 of a pound heavier on the 95. Now the 95 does fit in there very nicely. The pipe is also suitably sized for a 95. The diameter is very large on the pipe. So that's actually, I think, a pretty cool engine to put in here if I was to build a Rebel Hot, and this is actually my 95 engine here that is designated for my T33 over there, but And the 60 does require some adapter mounts here, which the owner of this plane graciously shipped these. So when I first saw these, I had no idea what they were, and then I looked at the pattern and I was like, wait a sec, that looks like it fits perfectly. So those bolt onto the mounts and create nice mounting plates for the 60 turbine. Also the 45, I think, is exactly the same mounting strap. So anyways, that's the engine we're putting in there. So we're gonna get these bolted up to the engine. So then what we can do is get the engine put in place, and then we can get our pipe adjusted up and down, and that gets screwed into the wood structure right there. All right, so I'm going to talk you through what we've done here with the engine. So we've got our mounting brackets installed. Don't mind the yellow paint marker, that's just me doing some calculations and stuff, but we're ready to get the pipe mounted. Now I've gone ahead and put this all together. So I had the engine sitting in here. Beautiful wife was holding this up and getting it adjusted to the right spot. And I've got that marked out where I can install the pipe and get that installed and drilled and all that stuff. So essentially what I wanted to do here was get our depth figured out. So the depth of this bell mouth is very, very big. We're basically 60 millimeters from the start of the pipe to the end of the bell mouth. So on a big bell mouth setup like that, you want to always split the distance. So if your depth of your bell mouth is 60 millimeters like we have, then the end of the turbine exhaust cone should be at the halfway mark, which is 30 millimeters. So if we measure this out like that, so we're right at the end of the tail cone is 0, 30 millimeters is basically right on the end of our black mounting tabs. So initially I thought I was going to have to cut some of this to allow the turbine to sit deeper, but if we run this mount right to the end of the pipe like that, then the turbine is at the perfect depth in that bell mouth, and the pipe needs to come up a fair bit like that. So that's going to be a cool mounting system. These brackets are pretty nice to have and very, very handy, and it's going to make mounting this engine ultra simple. So next thing to do is we are going to get our pipe mounted. What I'm going to do here is hold this guy up, drill a hole through here, do one side first, and then make sure we're happy with the adjustments, drill the other side, and get the pipe fastened in the airframe. And engine is fastened in place. Worked out very nicely, happy with that result, and of course we need the customary shot up the tailpipe. And there we are, nice and centered, up, down, left, right. Great setup on this aircraft. Very, very nice. All right, so just flip the plane over here. Obviously last night we glued this piece in place, and I just want to show you guys what it looks like when we pull the tape off. So we may have a little bit of filling to do, maybe not. We'll see what it looks like. So cool, we have a little bit of sanding to do there to get rid of the excess. Nice, and a little bit of filling on that side to do, but basically we can paint this, I mean you could leave it raw the way it is. I may touch it up just with gray so it kind of blends into the wheel well opening, but ultimately the point of doing that was just to fill in that gap there. It looks like when CARF cut this opening they may have gone a little excessive, I don't know, but anyways, not a big deal. And we've got a little bit of an overhang here. So as long as the gear doesn't interfere, we're just going to leave that. But if we, you know, if the gear, once it's fastened, comes up and is close to this or is hitting this, then we just do a little bit of sanding there. It's probably 4 millimeters towards the back edge. So anyways, that worked out good. Nice and solid, nice and strong. It's definitely an amusing contrast with the F14 XXL in the background. Posted a couple pictures on Facebook the other day. This Rebel sitting here, F14 XXL in the background. It's hard to tell the difference in size. And then I posted the Rebel Hot on top of the F14 XXL, and very significantly different. So it's been a fun project so far. Video number 1 is going to wrap up here. We got a lot done. We obviously took a look at all the equipment. We got our nose stuff glued in, our tail section done, engine installed, pipe installed, so making some good progress on this aircraft. Next video, we're going to get into the wings. So it's going to be primarily focused around the wings. We'll do some of our organization on the front section, but I suspect the entire build process or assembly process on this aircraft is going to be about 3 videos from start to finish. So look forward to that. And thanks guys so much for watching. Don't forget to check out channel membership. If you want to see the videos early, channel membership is the way to do it. There's some links on the channel. There's some links down below. But channel members, you guys get to see the videos a couple weeks before they get released on YouTube. So that's one of the perks of being a channel member. It is a paid thing, but I enjoy the support as well. And it's kind of fun giving you guys different perks. So thanks guys so much for watching, and we will see you in the next video.